Morning, dear students. Hope you are doing good. Wherever you are, stay safe. Dear students, we entered into the 6th unit. Already we have seen various treatment technologies in the 5th unit, and we are in the stage where we are treating. We are in the stage where we are ready to supply water to the public. In all the previous classes, we learned different treatments where we can remove the unnecessary components and also the required components if they cross their permissible levels. This is fluoridation. We discussed already in this 5th unit. Adding of fluorine. Just we are increasing the fluoride concentration in the water with the help of the substances like CaF2, sodium fluoride, silicofluoride, and the concentrations will be like this based on the temperature less than or equal to 18.3 degrees Celsius. At the time, the percentage of fluoride or is the percentage of fluoride substance to be added 1.1 to 1.3 ppm like this, and the temperature is 18.4 to 26.6 degrees Celsius. The same way when the temperature is greater than or equal to 26.7 degrees Celsius, these are the different concentrations of fluoride substances to be added to bring back the concentration of fluoride in the water for making water fit to the supply of or else to consumption. See here, defluoridation we discussed already. We are here, distribution of water. We already discussed methods of water supply where we have seen continuous water supply and intermediate system. Now we are discussing about layouts of distribution system. Here, layouts of distribution system. There are 4 types of layouts, or else there are 4 layouts majorly in water distribution. The first one is dead end system, and followed by grid system, circular system, radial system. See a dead end system. See, it is suitable. This system is mostly suitable for the cities or towns which are irregularly developed. The first point, it is suitable for the areas or else for the towns or cities which are irregularly developed. And the second one is, and the second point here to be discussed is one main pipeline will be laid along with the main road, and to that main pipeline the branches will be taken into the connection for supply of water. See here all the submain. See, this is the blueprint. This is the main line, and to this main line the sub branches, branch lines or branches will be taken, or as branch pipelines are connected to the main line. See here all the service lines, branch lines, all will be connected to the main supply line. See, when we have a look, all these are having dead ends. Here the supply will be stopped here, and it is stopped here, and it will be here and here. That is the reason we just named it as dead end system. See here all the submains in both the direction along the other roads connected to the main, and from those the submains and submains likewise the system will goes on and will be end at the at one particular point. And here the third point to be discussed in this layout is these are initially cost is cheap. Initial cost is cheap, and the required diameter of pipe can be determined easily. Initial cost is cheap and required diameter of pipe can be determined easily. See, the main disadvantage of this system is if any repair occurs, the whole locality beyond the point should be suffered during the repair period. If any repair works, if any repair occurs, the whole locality has to be suffered beyond that particular repaired point. As seen, as is here, as the water is storing, as the water is sucking at the end, because it is the dead end, there is a chance of forming bacterial contamination, and it may not meet the demand of fire as the water goes only in one direction, and it may not meet daily consumption during festival and holidays. These two are the things which we need to remember. See, dead end system. In the dead end system, this is the the blueprint you should mention in the examination. We should draw this dead end system. So one main pipeline will be laid along the main road. To that main pipeline, the branches, services and branch lines will be taken in such a way they can supply to the water. And this system is mostly adapted to the cities or towns which are irregularly developed. Second point. Third point, initial cost is cheap and even maintenance also cheap. But the drawback is whenever fire accidents occur, it may not meet the fire, it may not meet the amount of water to be supplied for controlling fire, because this is one-way pipelines, dead end system. Whenever fire accidents occurs, as the water is moving only in one direction, here the water flow cannot divert. We may not divert the water flow, and this is the drawback here, no? And one more thing is, if any repair occurs in this type, the whole locality beyond that point, or else from that point, should suffer, because the whole pipeline is, because the whole water supply is based on the one main water supply line. That is the reason if any repair occurs, the whole locality beyond that point will be suffered. That's what I mentioned. See here, along the main road, the main pipe will be laid. All the submains are connected to the main line. See here, one more thing. See, this is the grid system. Sorry, here I mentioned already. The main disadvantage of this system is if any repair occurs, the whole locality beyond the point should be suffered during the repair period. As the water is storing, see here, the point is, as the water is passing from main line to service line, and it will be stored here itself. This is a dead end. Because of the excessive or else long storage of water in the pipes, there is a chance of attracting bacterial contamination. That's why I mentioned here. And it may not meet the demand of fire as the water goes only in one direction, and it may not meet the daily consumption during the festival and holidays. This is about the dead end system. We are discussing about layouts of distribution system, and the next one is grid system. This is also familiar as rectangular system, and it is more convenient for the towns developed with roads of rectangular layout. See here, this is very familiar. This is very familiar system, and as the rectangle, and it is more convenient for the towns developed with roads of rectangular layout. See, have a look over here. This is the rectangular layout, whereas in the previous case, this is the layout of dead end system where the water is flowing in one direction. From this direction, all the service lines and branch pipes are connected to the main pipeline. There is a bacterial contamination due to the large period of storage of water. See here, in grid system, this system is improved to distribution system over dead end system. See here, the first thing you keep in mind is this is familiar as rectangular system. The other name of grid system is rectangular system, whereas dead end system with the other name of dead end system is tree system. See here, grid system, the other name of grid system is a rectangular system, and is more convenient for the towns developed with the roads of rectangular layout. Whereas the previous one is, this is mostly adaptable, or as this type of system you may be observed the cities which are irregularly developed, right? And here this is where the city has developed, with rectangular layouts, or else where the developed roads of rectangular layout is existed, this system is mostly suitable, and it is advanced system to the dead end system. The next point is this is advanced system or else advanced distribution system to the previous one. That's what I mentioned here. This is a system as an improved distribution system over dead end system. See here, water can circulate freely in the entire distribution system as all the dead ends are interconnected with each other. See, whereas here, have a look over here, all these are the dead end. Because of these dead ends, water is allowed to store for a long period of time. As the water is storing long period of time, it may attract bacterial contamination. Whereas in this case, as the water is freely circulating, all the dead ends are interconnected. That means the bacterial contamination is almost reduced due to the, because we avoided the large period of storing water, or else we are avoiding the storage of water at the dead ends because all the ends are intercircularly connected to each other. That's what they mentioned here in this point. Water can circulate freely in the entire distribution system as all the dead ends are interconnected with each other. See, one more point which we must remember in this system is along the main road, the main line will be laid. All the sub-mains are connected to the main line at opposite directions along the other minor roads. See here, this is the main pipeline and opposite directions. See here, the sublines are connected to this main line, and these are the circularly connected. I mean, from this area to this area. See here, water contamination is, so one more point you must remember here, no? Along the main road, the main line will be laid. All the submains are connected to the main line at opposite direction along the other minor roads. See here, the main line is laid along the main road, and to this main line, the submains are connected in opposite direction to the minor roads. That's what I mentioned here. See here, along the other minor roads. This is the main road. This is the main road where the main pipeline is laid. To this main pipeline, the sub branches or else branches are connected. Branch pipelines are connected to this main line in opposite direction along with the direction of minor roads. See here, next point is it requires more number of pipelines and valves because it is circular system, no? Because to regulate the flow, it requires more number of valves, more number of pipelines and valves, and it is easy to design and most efficient supply system than any other type of distribution. See here, this is we are discussing. Opposite, during repair works, only limited area will be affected as the water will circulate in all the directions. See, in the previous case, see, if any repair occurs, the whole locality beyond the point should be suffered during the repair period. Whereas here, in this case, during repair works, only limited area will be affected as the water will circulate in all the directions. See, as the water is circulated in one direction in the previous case, the whole locality will be in suffer because the water is passing in one direction. Whereas in this case, the water is circulating in all the directions, only limited area will be suffered during repair works. Next point is the friction losses are minimum as the water reaches every point from more than one route. See here, the friction losses are minimum as the water reaches every point from more than one route. See here, routes are different. See, water is reaching as all these are interconnected. That's why we just mentioned as gridiron system where see all these, as these are the interconnected, the friction losses are minimum. Possibility of water contamination is less as all the pipes of system are interconnected. In case of fire accident, adequate water can be supplied because to control the fire by closing the needed valves to divert the flow. See, as the water is passing different minor roads, the flow will be controlled by keeping valves. Because of valves, by diverting flow, we can control any fire accidents whenever occurs. The main disadvantage or initial cost is high. Number of required walls also more. Highly technical expertise required and difficult to design, and the cost is more for maintenance. See here, first of all, we'll discuss one more time. This is the improved distribution system to the previous dead-end system, and this is adaptable to the cities which are developed, and which city has having the rectangular layouts. This is mostly adaptable. Here, as all ends are connected to each other, water can circulate freely. See, along with the main road, the other minor branches will be connected to the main branch line towards the minor road directions. And during repair works, only limited area will be affected. And one more thing is friction losses are minimum as the water reaches every point from many locations, or as from more than one route. So water contamination is less because the water is circulating continuously. And during the fire accidents, we can meet the requirement by keeping the wall off. See here, the disadvantage is initial cost is high, and as the number of walls has to be fixed to control or regulate the flow. Highly technical expertise is required and difficult to design, and cost is more for maintenance. This is grid system. Next one is about circular distribution system. This is the city. It is mostly adaptable for well-planned localities. In the previous case, this is irregularly developed cities, dead-end system, and the second one is the cities which are having mostly rectangular layouts, and this is well-planned localities. See, in this system, every distribution area is divided into circular blocks or square-shaped blocks. Water mains are laid all the sides of circular blocks of square-shaped blocks by covering entire area. See here, water main. This is the main. Water was circular. You see here, water is moving towards all the directions, circular. Well developed. The area is divided into different circular zones or square-shaped zones, and water will be supplied all the directions. See here, water mains are laid all the sides of circular blocks or square-shaped blocks by covering entire area. All the branches and sub-mains are interconnected along the inner roads in such a way every point get the water from two directions. See here, water will get in two directions. See here, two directions. Everywhere the water will get in two directions. That means every point water will get to every point water will come more than one source, more than one or two sources. See here, it requires more number of pipelines and walls. It is easy to design and most efficient supply system than any other type of distribution system. It can be adaptable for very planned cities or as well planned cities. One more time. This is where it can be adaptable for well planned cities, and the water, the system, every distribution area is divided into circular blocks. Every distribution system is divided, divided circular blocks, square shaped blocks. Entire those circular blocks, water mains will be laid. All the branches and sub-mains are interconnected along the inner roads in such a way every point get the water from two directions. It requires more number of walls and pipelines. It is highly efficient supply system for well-planned localities, and it is easy to design also. Okay, this is about the circular system, and the last one is fourth one is the radial system. Here, radial system, it may not possible in India. Why? Because see here, the roads must be laid radially from the center point, which is practically not possible. It is the reverse of grid system, and water flows out from the point. As you see here, from one point, the water will be distributed into all the directions. That is the reason I mentioned here. The roads must be laid radially from the center point. It is not possible in the countries like India, everywhere. It may be possible at particular some areas, but it is not possible for all the areas. It is reverse of grid system, and water flows out from one point as shown in the figure. From one point, water will be supplied and water will be flowed. In this system, the whole district is divided into different zones. For every zone, one reservoir will be provided at the center point. The whole district is divided into different zones. At every zone, see, point is, for every zone, one reservoir will be provided at the center of the zone. water will be supplied very quickly as the water lines are radial from the reservoir. Water will be supplied because the water lines are laid radially from the reservoir. This is about the radial system. See here, the first case, water is, the main pipeline is laid along the major road, and to all the directions, one subline will be connected. Likewise, the connections will be given to all the houses as long as they existed. This is mostly adaptable for irregular cities, developed irregularly. As the dead end system, the name is dead end system, and even the water passage is stopping arrest. Closing at one particular point, there is a chance of attracting bacterial contamination. Why? Because the large storage of water is observing in the pipelines. Large period of storing water is observing in the pipelines, because water may not flow from this end to anywhere else. At this particular situation, it may attract the bacterial contamination. See, here grid system is mostly adaptable to the city which are having rectangular layouts, and it is advanced, and it is more advanced to the previous dead end system. Here water will circulate freely, so there is no chance of bacterial contamination. And here from one, as the water is passing through, as major pipeline will be laid along the major road or else main road, to that main road, the pipelines are as branch lines will be connected to the main pipelines. Water will circulate as all the branch lines are connected to each other. So there is a reduced bacterial contamination. We may not observe bacterial contamination even as all the sub canals or branch lines are connected to each other. That's what I mentioned here. Here, all the mains are connected to the main line. All sub mains are connected to the main line at opposite direction on the other main roads. So during repair works, only limited area will be affected. See, one more thing is, the possibility of bacterial contamination is less. I see water can circulate freely in the entire distribution system as all dead ends are interconnected to each other. One more thing is, whenever fire accidents occurs, water can be diverted as it is having number of valves. Initial cost is high. I need high technical expertise. Cost is more for maintenance. And coming to circular distribution system, water flows in all the direction as the entire area has been divided into circular blocks or square shaped blocks, and water will be supplied from all the directions, and every point water will get from one or 2 points, in this case here, all the branches submains are interconnected along the inner roads in such a way every point get the, just now I said that, no? See, it requires more number of pipelines and walls. It is most efficient supply system, and it is adaptable mostly for all the well-planned localities. Here, from one particular point, water will be distributed. This is called as a radial system. See here, from one point, the roads will be, see here, or because the roads must be laid radially from the interpoint. See, this is may not possible everywhere in the countries like India. Why? Because the roads must be laid radially from the center point, which is practically not possible. In this system, entire district has been divided into different zones. For every zone, one reservoir will be provided at the center of the zone. Whereas here, in this case, the entire area has been divided into circular blocks or square-shaped blocks. Here, entire area is in this system, the whole district is divided to different zones. For every zone, one reservoir will be provided at the center of the zone. Water will be supplied very quickly as the water lines are laid radially from the reservoir. This is about the layouts of distribution system. In the previous case, we discussed the methods of water supply. Today we discuss layouts of distribution system. Hope you understood. If you have any doubts, you please contact me either phone, message, or mail. Thank you.